Imagine that everything in the universe, every star, every atom, every thought of yours, is made of the same mysterious thing. Einstein discovered that mass is just super-concentrated energy, and that a tiny piece of matter the size of a coin has enough energy to light up an entire city for days. Since then, we've learned to split atoms, build lasers, and even send messages through space using energy. But even after centuries of studying, we still can't answer the most basic question: is energy a real substance, or just numbers we invented to understand how things move and change? Are we literally made of pure mathematics? Subscribe to the channel, leave your like and comment from what part of the world you're watching, because now I'm going to tell you everything. What makes everything in the universe happen, from the biggest stars to the smallest bug. You may not see it, and you cannot pick it up or put it in your pocket. Still, it is always there, making things move, light up, make noise, or even simply change. This thing is energy. Energy is a part of everything you do and everything that exists. It is the secret behind every action in nature, every machine, and each thing that lives, breathes, or grows. Imagine you wake up in the morning, you open your eyes, move your arms, and get out of bed. Right away, your body is using energy. You eat breakfast, and your body changes the food into more energy. You may listen to music, talk to your family, or look out the window. The sounds you hear and the light you see are also possible because of energy. It does not matter if it is morning, afternoon, or night. Energy is working all the time, everywhere. If you stand still and look around, you can find hundreds of ways energy is making things happen. The sun shines high in the sky. Its light is full of energy. This energy warms your skin, helps plants to grow, and lights up the whole world. If you see a car driving by, it uses energy to move down the street. If you hear a bird sing, the sound reaches your ears because energy travels through the air. Every leaf that dances in the wind and every river that flows is part of the story of energy. But what is energy really? Energy is not a kind of thing you can hold or see with your eyes alone. If you try to look for just energy, you never find it sitting all by itself. Instead, you always see what energy does. You notice it because things around you move, change, shine, or heat up. This makes energy special. Energy is not just one thing like a rock or a tree. It is a way to talk about how something can do work or change in some way. Think about a ball rolling across the floor. When you give it a push, it begins to move. That push gives the ball energy, and that energy turns into motion. If you stop the ball with your hand, it might feel warm from moving. That warmth is energy too. This shows you that energy is not only about moving things, it can also show up as heat or even light. When you see a flame in the dark, what you are really seeing is energy as light and heat. A candle may seem small, but it fills a room with both kinds of energy as it burns. Energy is in every corner of the universe. No matter if it is as tiny as an insect or as big as the sun, nothing can happen without energy. It is what lets things move or change. And if energy were gone, everything would stop. The air would not blow, rivers would not run, people, animals, and plants could not live. The world would become still and silent. So energy is not just something scientists talk about in books. It is what ties everything together and makes life possible. To help you understand energy better, you can imagine some simple moments in your day. When you walk, you use energy from food you have eaten. When you turn on a lamp, you use energy that starts far away at a power plant. When you use a phone, you use energy that is stored in a battery. Even when you feel cold and put on a sweater, your body is trying to keep its energy from leaving too fast. Energy can come from many places. It can come from the sun, the wind, from burning fuel, or even from your body. But wherever it comes from, energy is always behind everything you see and do. For a scientist, the sun in the sky, a rolling ball, a singing bird, and a growing tree are all examples of energy at work. Sometimes people wonder if energy is real or if it is just an idea. If you went looking for a bag of pure energy, you would never find one. That is because energy does not sit in a corner of a room waiting for someone to find it. Instead, you always see energy as part of something else, as motion, as sound, as light, or as warmth. This is a very strange but important idea. Energy is always there, but it hides in the things it changes or moves. Scientists have spent a long time asking, what is energy? They have found out that energy is not just a single thing. It can show up in many different forms. You can have energy because something is moving fast, because something is hot or cold, or even simply because something exists. The world is full of energy in many ways, and every time you look, you see its effects. In nature, energy is part of even the smallest parts of matter. Everything around you is made of matter. With your hands, you can hold a stone, a glass of water, or a book. These things are all made of matter, and inside every bit of matter, no matter how small, there is energy. Everything from the largest planet to the smallest grain of dust is packed with energy. A long time ago, a famous scientist named Albert Einstein showed everyone a new way to see energy and matter. He found out that matter and energy are linked. This means that even a single grain of sand has a lot of energy hidden inside it. They are different, but in a way they are also the same. Sometimes, under special conditions, matter can turn into energy, and energy can turn into matter. This shows us that energy is not just a simple thing. It is a very deep part of what makes up our universe. Now imagine you are outside and notice a sunbeam touching your face. The warmth you feel is energy. The sun is very far away, but its energy travels all the way to you in the form of light. That light helps plants grow, warms the planet, and lets you see everything around. Without the sun's energy, the earth would be cold, dark, and empty. Look at a bird flying in the sky. It flaps its wings using energy from food it has eaten. The bird's muscles use this energy to move. When you listen to the bird's song, that is also energy. The sound comes to your ear because the bird's song sends energy through the air in tiny waves. Even your own body is filled with energy all the time. Your heart beats, your lungs fill with air, and your mind thinks new thoughts. These all use energy. Every time you blink or smile, energy makes it possible. When you play or run, your body changes energy from food into movement. Suppose you see a car driving past your home. That car uses gasoline to run. When the gasoline burns, it gives energy to the engine. The engine uses that energy to turn the wheels and move the car. If you ride a bicycle, your muscles use energy from food you have eaten. The energy turns into the movement of the bike and the warmth you feel after pedaling fast. Energy is also what lets us use many tools and machines. When you flip a light switch, you use electrical energy to light up a bulb. When you heat water to make tea, you use energy to make the water hot. When you watch television or call a friend, you use energy stored in wires or batteries. But energy is not only in the things that are big or easy to see. It also lives inside the very smallest pieces that make up everything, like atoms and molecules. Atoms are so tiny you cannot see them, even with your eyes open as wide as possible. Inside each atom there is energy holding it together and letting it move. This energy is part of what makes all matter possible, from your desk to the stars in the night sky. You might wonder how energy moves from one thing to another. Energy can change from one form to another. For example, when you throw a ball up, you give it movement energy. As it goes higher, that movement energy slowly turns into stored energy. When the ball falls back down, the stored energy changes into movement energy again. Every time energy changes form, it makes new things happen. Even though you always see energy's effects, you never run out of new things to notice. There are so many ways energy can work. Some energy is easy to see, like the light from a lamp. Some energy is quiet and hidden, like the energy inside the food you eat or the cells in your body. Sometimes energy is noisy, like the sounds you hear. And sometimes it is invisible, like warmth on a sunny day. Energy links everything together. It makes things happen, lets us learn, play, and grow, and is the reason anything in the world can change. Without energy, the universe would be cold and still, with nothing moving or growing. Energy is the mover and changer of everything that exists. Remember, when you see things happen, like water running in a stream, clouds rolling in the sky, or even a flower opening its petals toward the sun, all these events can happen only because of energy. It does not matter where you are, in a city or on a mountain, in the bright sun or in the dark night. Energy is always there. It is a friend that works quietly, making all things possible. Now you know you cannot see energy alone and you cannot put it in your hand. But when you look at all the things happening in the world, you are really seeing the work of energy everywhere. It is the secret power working inside stars, in the drop of water, and in each breath you take. This is why, from the oldest times to today, people are always curious about energy. They look for ways to understand it, use it, and save it. Every discovery about energy helps us live better, grow more food, build new machines, and keep the earth healthy. Energy has always been part of life's greatest mysteries, and it is the key to how the universe works. Everything that changes, moves, grows, or shines is using energy in one way or another. You, your friends, the animals in the forest, the rivers, the wind, and even the stars above are all a part of the story of energy. It is everywhere, and it will always be there, making things happen. Energy is not one single thing. It shows up in many different ways. Everywhere you look, you can see many forms of energy. If you look closely at what is happening around you, you will notice that the world is always busy with many kinds of energy, from the light that lets you see, to the heat that keeps you warm, to the movement all around you. Each of these is a special kind of energy. Light energy is easy to notice. When you turn on a lamp, you can see the glow it makes. The sun is the biggest source of light energy on Earth. The sun sends out light every day, and this energy spreads over the land, water, and all living things. Without the sun's light energy, there would be no plants, no warm days, and no color to see. At night, you may notice light coming from the moon and stars, but this light is much weaker. Lamps, candles, and even screens on your phone or computer also give out light energy. Every time you see something, it is because light energy has reached your eyes. Heat energy is another form you know very well. You feel it when you stand near a fire, when you drink a warm cup of soup, or when the sun shines on your face. Even when you rub your hands together, they get warmer. This is heat energy. Your body makes heat energy every second, and so do animals and even machines. Some things are hot and others are cold because of the amount of heat energy they have. If you use a stove to cook food, you add heat energy to the food and it cooks. The warmth in your home during cold days comes from heat energy. Movement energy is called kinetic energy. Anything that is moving has kinetic energy. When you run, jump, walk, or throw a ball, movement energy is there. When you see cars in traffic, bicycles on the road, birds flying, or water moving in a river, you are watching kinetic energy at work. It does not matter if something is moving fast or slow. As long as it is moving, it has kinetic energy. Another kind of energy is stored in objects. This is called potential energy. You can find it in many places. If you stretch a rubber band between your fingers, the band is storing energy. If you lift a book above your desk, the book is also storing energy. Even a battery that has not been used is full of stored energy. This energy stays hidden until something happens to release it. When the rubber band snaps back, or the book falls, or you use the battery in a flashlight, the stored energy changes into kinetic energy, light or heat. There is also chemical energy. This energy is inside things like food, fuels such as gasoline and wood, and even in batteries. When you eat food, the energy in it is released inside your body. When you burn wood in a fire, chemical energy becomes light and heat. A battery holds chemical energy, and when you use it in a toy or a remote control, the chemical energy changes into movement or light. Electric energy is part of your life every day. When you plug something into a socket or charge a device, electricity flows through wires. This electric energy makes lights shine, computers work, and many machines run. The energy you use in your home mostly comes from electricity. Even lightning in the sky is a huge burst of electric energy. Sound energy is something you can hear. If you clap your hands, you make sound energy that travels through the air. Every voice, every note of music, or the sound of a dog barking or a bell ringing is made with sound energy. It moves in tiny waves from the object to your ear, so you can hear different sounds. There is also energy that is not easy to see or feel. Inside every tiny atom there is nuclear energy. This energy holds the parts of the atom together. In some cases, like in the sun or in nuclear power plants, this nuclear energy can be released, making a lot of light and heat. Inside your body, you are using energy all the time, even when you sleep. Your body changes the chemical energy from food into the movement of your muscles, the warmth you feel, and the power your brain needs to think. Every heartbeat and every breath use energy. These different forms of energy can turn from one kind into another. If you drop a ball, the energy it has from being held high, potential energy, changes into movement energy, kinetic energy, as it falls. When the ball hits the ground and bounces, some of the energy turns into sound energy, and a bit of warmth, heat energy. When you eat food, your body takes the chemical energy inside and uses it to move, grow, and stay warm. Water running down a hill has movement energy. We can use this movement to turn machines that make electric energy. This electric energy can then light homes, run computers, or cook food. Some machines, such as solar panels, change light energy from the sun straight into electric energy. Energy is always around you and always being changed from one form to another. People have learned how to use these forms of energy to help with many parts of life. We use light energy to see at night, heat energy to cook and keep warm, electric energy to power cities, and sound energy to talk and enjoy music. Scientists and engineers work hard to use energy in new ways, turn one kind of energy into another, and store energy for when it is needed. Plants use light energy from the sun in a very special way. With the help of water and air, plants change sunlight into food with a process called photosynthesis. The food made by plants holds chemical energy. When people or animals eat these plants, that energy moves into their bodies. In this way, the sun's energy is passed along from plants to animals and then to people. If you look at a battery, it is storing chemical energy. When you put the battery into a flashlight and turn it on, the battery changes its chemical energy into electric energy. The electricity flows through the flashlight and the bulb changes the electric energy into light and heat. All these steps show how energy moves from one form to another. When you ride a bicycle, you use chemical energy from food. Your muscles use the energy to push on the pedals. The energy turns into movement and the bike rolls forward. If you go very fast and then stop suddenly, the wheels and brakes will feel warm. This is because some kinetic energy has changed into heat energy by the brakes. Some things store energy and hold it until needed, like water behind a dam, food in your cupboards, or gas in a car's tank. When you use a machine, drive a car, or light a stove, you release that stored energy and it turns into other forms. Energy often moves in cycles. For example, the sun sends light energy to Earth. Plant leaves catch this energy and store it as food. Animals and people eat the plants and they use the energy to live and move. When people use energy, some turns into heat that goes back into the ground or air. In this way, energy keeps moving, changing and flowing everywhere. Because energy is always changing forms, it never stays still. Sometimes changing energy from one form to another is very easy, like turning on a lamp or charging a phone. Other times, it takes special tools like power plants, batteries, or engines. Many machines help people turn one form of energy into another. Power plants make electricity from the energy in burning coal or from water flowing through a dam. Windmills catch the movement energy of wind and turn it into electricity. Cars and trucks burn fuel to change chemical energy into movement. Even a simple fan or blender at home turns electric energy into movement energy. Sometimes the way energy changes form is not perfect. A light bulb gives both light and warmth, but most of the energy ends up as warmth. An old car might use a lot of fuel, but much of the energy ends up as heat from the engine, not in moving the wheels. This is why people look for better ways to use and save energy and to waste less. All around the world, people are finding new ways to use the forms of energy around us. Solar panels allow people to use more energy from the sun. Wind farms use the wind to make power for homes and cities. Batteries are getting better so people can store more energy for their phones, cars, and homes. Some forms of energy are easy to use again and again, like sunlight, wind, and water moving in rivers. Other forms, such as gasoline, coal, or natural gas, are used up after burning. These fuels come from the ground, and it takes a very long time for more to be made. This is why many people are working to use more energy from the sun, water, and wind, and less from the fuels that can run out or harm nature. No matter what, all the kinds of energy you see, hear, or feel work together to make the world full of life, movement, and change. Scientists are always learning more about energy, trying to understand new ways to use it, and finding the best ways to keep the world healthy and bright. Inside every part of your life, energy is quietly doing its work. When you brush your teeth, go to school, play a game, eat dinner, or get ready for bed, energy is moving and changing, helping you and the world around you. From the tiny ticking of a clock to the huge waves in the ocean, many forms of energy are always at work. All of these different types of energy help us in our daily lives. They give us light to see, warmth on a cold day, movement to get where we want to go, and the ability to hear voices and music. Every machine, every plant, every animal, and every person depends on at least one form of energy to do its job. The light from a tiny firefly or the wind in a giant storm both come from energy. There is even more to learn about how all these forms of energy are connected. They are not separate things, but ways energy can appear and change. When you look at a bright flower, listen to a song, feel wind on your face, or charge your phone, you are seeing many kinds of energy working together. As scientists and inventors study energy, they discover new forms and ways to use energy wisely. By learning what energy is and how it changes, everyone can use energy better, share it more fairly, and take care of the planet. The different forms of energy, light, heat, movement, stored, chemical, electrical, sound, and nuclear, make the world dynamic and exciting. They explain why the sky is blue, why music can be heard, why food gives you power, and why machines work. Every day is full of energy turning from one kind into another. Understanding all these forms of energy helps explain everything from the most basic daily activities to the greatest wonders in nature. Whether it is the bright sun overhead, the taste of a fresh apple, the rhythm of your heart, or the shining stars far away, you can see and feel the many faces of energy at every moment of your life. Energy, in all its forms, is always present, ready to move and ready to change the world around you. When you look at all the different forms of energy moving and changing in the world, light from the sun, heat from a fire, electricity from a battery, food turning into movement in your body, it is easy to think of them as separate things. But there is a very deep idea in science that brings energy and matter together in a way that connects everything in the universe, from the tiniest piece of dust to the biggest star in the sky. Matter is everything that takes up space and has mass, like rocks, water, air, people, animals, plants, and even the smallest particles you cannot see. Matter looks, feels, and acts differently in many objects. Even so, whatever its form, all matter is tied closely to energy. Long ago, scientists wondered why matter and energy both seemed important for explaining how the world works. They noticed that matter can move, get warm, change shape, give off light, or make sound, but always by using or giving up energy. When you eat a piece of fruit, your body uses the energy inside the fruit, and that energy comes from the matter of the fruit. When you burn a log, the matter in the wood changes, turning into ash, smoke, and a lot of heat and light. That is energy. It was a scientist called Albert Einstein who showed that matter and energy are strongly linked. He wrote a very famous idea, E equals mc squared. The letter E stands for energy, M stands for mass, and c is the speed of light written out twice because it is squared. What this means is that every small bit of matter holds a very great amount of energy inside it, even when you cannot see or feel that energy. When you think about the world, you can see clues about this link everywhere. For example, if you look at the sun in the sky, you probably know the sun is sending light, heat, and energy down to the earth all the time. But where does all this energy come from? In the very center of the sun, deep below its surface, tiny pieces of matter are changing. Parts of the sun's matter join together or split apart, and when this happens, a very small amount of matter is turned into a huge amount of energy. That energy travels out as sunlight and warmth. Every time you see the sun's light, you are seeing energy that once was hidden inside matter. The connection is not only in the sun. The same idea is true anywhere matter can turn into energy or energy can turn into matter. There are only a few places in your daily life where you can see matter changing fully into energy because it takes special conditions that do not often happen on Earth. But the connection is always there, inside everything. This connection is very important because it helps explain why the universe works as it does. Before this idea, people thought matter was just solid stuff and energy was something different that moved around or made things work. But now we know they are not truly separate. Every object you can see or touch, your hand, a stone, a glass of water, is really a way that energy is held in the form of matter. When you eat food, you see energy turning from one form into another. Plants use light energy from the sun, turning it into chemical energy in their bodies. When you eat an apple, your body gets energy from the matter inside the apple. This energy lets your muscles move and your mind think. In this way, energy moves from light to plant, to food, to person, always flowing forward. Inside things much smaller than an apple, the same story repeats. An atom is a tiny part of matter, much too small to see even with the best eyes. Inside every atom, there is a center called a nucleus. The nucleus is made of even smaller pieces. These pieces are held together by a very strong force. When certain atoms change, the nucleus can let go of some of its energy. This happens in the sun and also in special machines on Earth called nuclear power plants. When the nucleus changes, a very tiny bit of matter disappears, but a large amount of energy is released. Even though matter and energy sometimes change forms in extreme ways, most things you see each day do not turn matter into energy, or energy into matter. Usually, energy only changes from one kind to another inside matter, or moves from one place to another. Still, the knowledge that all matter and energy are linked helps people understand why nothing is ever truly lost in the universe. Energy can be hidden in matter, waiting to be used or released. There are many examples of this idea. When you see a glowing light, electricity running in wires is changing to light and heat. The wires stay the same, but the energy inside them moves and changes form. When you burn gas in a car, the matter of the gasoline changes, and the chemical energy inside the gas moves the car's wheels and becomes heat and movement. Even in your own body, this happens all the time. The food you eat gives you new matter and new chemical energy. Your body uses this energy to move, grow, and stay warm. When you breathe or make a muscle move, you are changing chemical energy into movement, heat, and the work your body does. Sometimes you can see how important the connection between matter and energy is when something very hot or powerful happens. On Earth, there are volcanoes which throw out hot rock and ash. When the volcano erupts, the matter inside the Earth is changed into flows of very hot liquid, huge clouds of ash, and a large burst of heat energy. The matter in the Earth's crust turns into other forms of matter, but some energy is released as well. Lately, people have built very special machines called particle accelerators. In these machines, tiny parts of matter are made to smash together at very high speeds. When they do, the parts can break apart and new particles can be made. Some of the matter can even become energy, which can be measured. Scientists use these machines to learn more about how energy and matter are the same in some ways and change into each other in others. In the sky, far from Earth, there are even more clear signs of this connection. Stars, like the sun, are huge balls of matter. Inside them, high heat and pressure cause atoms to combine. This changes matter into energy, which shines out as starlight. At the end of a star's life, sometimes a huge explosion called a supernova happens. In the moment of the explosion, a very large amount of energy bursts out and some matter disappears. This light and heat travel for a long time across space, sometimes for millions of years, before reaching our eyes. On Earth, the matter in living things is always changing too. Plants take water, air, and energy from the sun to grow. Animals eat plants or other animals to take in energy. Even after something living dies, the matter in its body is changed by nature into soil and air. Through every stage, the energy inside the matter is either used, stored, or given off as heat or movement. You might want to know if it is ever possible for matter or energy to just appear or disappear in the universe. Scientists say they cannot. The total amount of matter and energy together stays the same. If energy seems to be gone, it has only moved somewhere else or changed form, even if you cannot see it anymore. This rule is very important and helps scientists know what will happen in nature. Now, you can start to see why the connection between matter and energy is so important. Every object you know and every bit of energy you feel or use is just a different way that matter and energy show up in the world. They are not truly apart from each other. They are two sides of one very big idea. Sometimes very special things happen in the universe. In the beginning of everything, scientists believe there was a huge burst of energy. As time passed, some of this energy turned into matter, all the stars, planets, rocks, water, and living things. Even today, deep in space, energy and matter can change back and forth in the most extreme places. In your own life, you use this knowledge every day, even if you do not think about it. When you light a match, you use the energy inside the wood. When you eat and play, you use energy that was once light from the sun. Every part of your body is made of matter and holds energy. Even invisible things like the air you breathe are matter filled with energy. The oxygen in the air lets your body turn food into energy. The carbon dioxide your body sends out is a different kind of matter, but it still has energy inside. Everywhere you look, the movement, warmth, and life around you come from the mix of matter and energy. Every building, road, mountain, ocean, and living being is built from matter. But inside all that matter, there is an invisible store of energy, sometimes locked up for a long time, sometimes used and replaced every day. The matter does not always look or feel the same, but the energy inside it can turn into heat, movement, sound, or light. Even the Earth itself is a big mix of matter and energy. Deep below the surface, rocks melt and flow because they have energy from long ago. The air moves because the sun's energy heats it up. Water moves and changes, carrying energy with it. High above, energy from the sun powers winds and storms, and plants catch sunlight and store it as food. Learning about the ways matter and energy connect helps people explain many things. If you know that a cup of hot tea cools down, you know heat energy moves from the tea to the air and to the table. If a car slows down, the movement energy changes to warmth in the tires and road. When you look at a rainbow after it rains, you are seeing sunlight bending in the water droplets. The light energy leaves the sun, travels through space, and then becomes the colors your eyes can see. Scientists learn more about energy and matter every day. They measure how much energy is hidden in different objects. They study the movement of atoms and particles. They look for new ways to use the energy inside matter, or to turn sunlight, wind, or flowing water into other forms of energy that people can use. Understanding that matter and energy can change into each other also helps people make better machines. Power plants that use nuclear energy to make electricity use this connection. New engines, batteries, and even rockets explore new ways to capture the energy locked in matter. Every invention that moves or lights up is really using the connection between matter and energy. Energy is also part of what helps scientists explain what happens far away in the universe. The way galaxies move, the way planets spin, the way stars are born and die. All of these depend on the dance between matter and energy. Even what happens inside your own body, in every cell, is guided by the exchange between matter and energy. When you hear about new discoveries in science, many times they are about finding new ways that matter and energy change and work together. Scientists look deeper and deeper, always looking for how matter holds and uses energy, and how energy can make new matter. The most important thing to remember is that matter and energy are not totally separate things. They can become each other in special conditions. They are both part of everything you see, touch, hear, eat, and use. This is why every part of life, from the smallest atom to the largest mountain, is made possible by the close friendship between energy and matter. Every person, Every animal, every plant, every piece of earth and air, every star and planet is part of the great story of energy and matter. Knowing about their connection helps explain why the world is full of movement, color, warmth, and change. This simple but powerful idea is at the center of understanding how both nature and technology work. By learning how matter and energy are joined, you can see how everything in the universe is built, runs, moves, and shines. This helps you find energy in the world, use it in daily life, and think about where it comes from and where it goes. Every part of life is touched by energy. In everything you do each day, energy is present, helping you move, think, grow, and even rest. It flows through your body, powers your home, makes your food, and gives you light to see and warmth to feel safe. When you sit quietly, when you run and play, when you learn or even just breathe, your body is always using energy. The world around you is full of energy all the time, and your daily life would simply stop without it. Think about the very start of your morning. When you wake up, your body has already used energy to keep your heart beating and your lungs working through the night. Your mind wakes up, ready to think and remember, because energy is moving in your brain. If you get out of bed and stretch, your muscles use energy to help you move. When you take your first breath after sleeping, your chest moves because of energy in your muscles. Breakfast is one of the first times you use energy from outside your body that day. The food you eat is full of chemical energy. This energy was made by the sun, stored in plants, and placed inside your meal by nature. When you eat bread, milk, fruit, or eggs, your body starts to change the food into new forms of energy that your cells can use. This is called digestion. Your mouth, stomach, and intestines all do their special jobs, taking the energy from food and making it ready for your body. Every action, chewing, swallowing, letting food move through your body, uses energy too. After breakfast, you might go to school or work. You might walk, run, ride a bicycle, or travel in a car, bus, or train. All these movements need energy. If you walk or run, your muscles get their energy from the foods you have eaten. If you ride a bicycle, your legs turn food energy into movement that makes the bike go. When you use a car or take the bus, a different energy is being used. In a car, energy comes from fuel, usually gasoline or diesel. When the engine burns this fuel, it changes the chemical energy in the gas into movement, heat, and sometimes sounds you can hear. If you travel by train or subway, there is often electrical energy at work. Electricity runs through wires or rails, powering the train's motors. The movement you feel is really electrical energy turned into movement by the train. In big cities, people travel using electric buses, trams, and elevators, all needing energy. Arriving at school or work, you find many more uses for energy. Buildings need energy for lights, computers, heating, cooling, and many tools people use. Electrical energy from power stations moves through wires and makes everything work. When you enter a room and turn on the light, electrical energy lights the bulb. If you use a computer or phone, you are using energy that is stored inside a battery or coming from the wall outlet. When you write with a pen, your hand uses energy. When you speak, tiny muscles in your throat use energy, and your voice produces sound energy that moves through the air. Even reading a book or thinking quietly uses energy because your brain's cells use a steady supply to work with ideas, store memories, and help you learn. During breaks, you might play with friends, run, jump, or play a sport. Your body changes food energy into movement energy. Muscles use stored chemical energy for every step, kick, or throw. When you play outdoors, energy from the sun warms your body and brightens the day. Sunlight also helps your body make vitamin D, which helps your bones and muscles. Even sitting still, you are using energy all the time. Your heart must keep beating. You need to breathe in air and let it out. Your body uses a small bit of energy just to stay the same temperature, especially if it is cold or hot outside. Later, you eat lunch or have a snack. Again, food gives your body fresh supplies of energy. The food often comes from plants like rice, potatoes, or vegetables. These plants took in sunlight, water, and nutrients from the soil. The energy from the sun is turned into food by the plants, then passed through the food chain. If you eat chicken or fish, the animal also got its energy from plants or from eating other animals that once ate plants. After school or work, you might go home, visit a friend, or go shopping. Modern life uses a lot of energy. Inside your home, you use many machines. These might be a refrigerator, a microwave, a washing machine, or a heater. Every machine uses energy to do work. The refrigerator keeps food cold by moving energy away from the inside and pushing it out. A microwave uses electricity to heat your meal quickly. Washing machines turn electricity into movement to clean clothes. Heaters and air conditioners use energy to keep your home comfortable. When you open the faucet to get water, pumps have moved that water from far away. The pumps use energy. Water may have been cleaned in treatment plants that also use energy. Even the pipes and tanks that hold water need energy during the process of building and repair. At dinner, you once again use energy from the food you eat. Dinner may have traveled from farms, factories, and stores, each trip using energy from oil, gas, or electricity. The food you eat is cooked with energy, maybe on a gas stove or an electric oven. If you eat ice cream or drink something cold, energy is used to keep things frozen or cool in a freezer or fridge. When the sun sets and it gets dark, more energy is used to light your home and streets. Light bulbs turn electricity into light. Some kinds of bulbs also make heat as they work. Tired after a long day, you may relax by watching TV, playing games, or listening to music. All of these activities need energy. The TV, game console, or music player uses electricity. The sound and pictures you enjoy are made possible by energy-changing form. Getting ready for bed, you might brush your teeth using an electric toothbrush, listen to music, or look at your phone one last time. Your room may be warmed by a heater or cooled by a fan. You pull up your blankets, made in factories that use energy. Even as you close your eyes, your body stays hard at work using energy to heal, grow, and store the things you learned that day. Outside your body, energy is still at work in the world. Streetlights glow at night. Cars and buses travel on the road, and in faraway places, power plants burn fuel, move water, or use wind and sunlight to make electricity for cities. Hospitals use energy to help people stay healthy. Supermarkets use energy to move goods, keep food fresh, and give light to show what is on the shelves. All plants and animals need energy too. A dog runs and barks using energy from its food. Trees and grass take sunlight, using it to grow and make green leaves. Birds use food to fly, sing, and stay warm. Even insects use tiny bits of energy to crawl, jump, or fly. In cities, energy moves through cables, pipes, and vehicles. In the country, energy comes from wind blowing, rivers running, and the sun shining. Every home, farm, and school needs energy every day to do important things. Streetlights, traffic lights, fans, heaters, radios, and alarms all need energy. Energy is not only something for big machines or cities. It is part of each small thing. It helps plants grow a new leaf, lets a cat stretch, or makes water drip from a tap. Even in a small house, energy is important for light, cooking, cleaning, heating, and cooling. When you talk to someone on the phone or computer, sound energy is turned into electrical signals that move through wires or the air. The signals travel far, using energy from many places. The phone or computer uses battery or wall power. Clothes are made with energy too. Cotton, Wool or man-made fibers are grown or created using machines and sunlight. Factories turn these into fabrics, then more machines cut and sew the fabric, and trucks use energy to move the finished clothes to shops. You use energy when you wash and dry your clothes at home. All the places you go every day work because of different kinds of energy. Schools, offices, sports fields, hospitals, and playgrounds depend on energy to stay bright, clean, and safe. Water comes to homes because pumps and pipes use energy. Food gets to stores using vehicles powered by energy. Every plant, animal, and person needs a steady supply of energy. Without enough energy, people and animals can feel tired, hungry, or cold. Plants may stop growing if they do not get sunlight and water. Communities work together to make sure there is enough energy for everyone. Some people work in farms, factories, or power plants. Others work in shops, hospitals, or offices, helping to use energy wisely. Homes, schools, and cities all need careful planning, so energy can be used without waste. Energy does not just come to you. It has to be made, moved, or delivered. Power plants make electrical energy using coal, gas, water, wind, or sunlight. Farms and gardens need energy to grow crops and take care of animals. Trucks, ships, and planes use energy to move things across the land, sea, or sky. At night, as you sleep, the world does not stop. Hospitals work through the dark hours, trains and planes move, and animals come out to hunt or play. Carefully, energy moves through every living thing and every place, always at work, even when you do not see it. Communities look for ways to use less energy and waste less. Lights can turn off when no one is in a room. Machines can be made to use less electricity or fuel. Food can be grown close to homes so it does not travel far. People can walk, bike, or use public transport to save energy. Changes in weather and seasons also show how energy works in everyday life. When it is cold, people use more energy to keep warm. When it is very hot, more energy is used for fans and coolers. In summer, the days are longer and the sun gives more energy to plants. In winter, less sunlight means plants grow slowly, and people and animals may eat more to keep their bodies warm. Even games and fun need energy. Swings in the park move because a child gives them a push. Ball games, swimming, or riding a bicycle all use up energy from food and drink. When you celebrate holidays or family events, energy helps you cook special food, light decorations, play music, and visit with friends or family who live far away. If you visit a hospital, you see doctors and nurses using machines to check your body, give medicine, or help people heal. X-ray machines, monitors, lights, and lifts all need energy. Clean water for drinking and washing comes because someone made sure pumps and cleaning stations had energy to work. Many things you own need new energy from time to time. Phones, computers, cars, and even toys run out of power and must be recharged or refueled. This is because the stored energy inside is used up as the device does its work. When you plug in your phone, it takes in new electrical energy so you can use it again. If you grow a garden, you notice energy in a very simple way. Plants need sunlight and water. You use energy to dig, plant seeds, water the soil, and watch things grow. The sun's energy fills the leaves, and in time, you can eat the food or smell the flowers you helped grow. Science and medicine use energy for discovery and health. Microscopes, telescopes, and cameras all use energy to help people see things far away or very small. Scientists use machines to explore deep in the ocean, in the sky, or even in space. Astronauts use energy from special fuel and solar panels to travel and live outside the Earth. All of these daily activities are made possible because matter and energy are working together everywhere, all the time. The food that gives you strength, the water you drink, the air you breathe, the clothes you wear, and the tools you use are part of this great flow of energy. people learn to use energy in smarter ways, so there is enough for everyone and for many years to come. The story of energy in everyday life is all about change and movement. It is about light turning into food, food turning into strength, and strength turning into action and ideas. Every person, animal, plant, and all the things people build and use share this energy, making the world lively and full of action every day and every night. As people move and work each day, all kinds of energy flow quietly in the background. The many forms of energy are not all the same. You can see them, hear them, feel them, or use them, each in a special way. Understanding these forms helps you see how every small action and every big machine needs energy to make things happen. Electricity is one of the most used forms of energy in homes and cities. It travels through thin metal wires, carrying energy silently from power stations to houses, schools, hospitals, and factories. When you flip a light switch, connect a charger, or turn on a fan, you are using electrical energy. Electricity can be made from burning coal or gas, using water in dams, or from solar panels that catch sunlight. Power plants sometimes use the movement of wind or the power of waves and rivers to create electricity. Once in the wires, this energy is ready to be turned into light, movement, or heat. Light is another important form of energy. The main source of light on Earth is the sun. Sunlight fills the daytime sky, helps plants grow, and warms people and animals. Without sunlight, there would be no green trees or food to eat. At night, people use electrical energy to light homes and streets with lamps or bulbs. You can also see light from fires, candles, and screens on phones, tablets, and computers. Even small insects and fish in the sea make their own light, called bioluminescence. Heat can be felt in many ways. On a warm day, the sun heats up the ground and the air. When you drink a hot tea or soup, you feel the warmth in your hands and mouth because of heat energy. Stoves, ovens, and heaters use heat to help cook food and keep people warm. Your body makes heat all the time, as do animals and even plants when they grow. Machines, cars, and computers also give off heat when they operate. Sound is a form of energy you hear but cannot see. When you speak, clap, sing, or play an instrument, you make vibrations in the air. These vibrations are sound waves that travel to your ears. Birds singing in the morning, music on the radio, or a dog barking outside are all made by sound energy moving through the air. Sometimes sound can move through water or even through objects. Under the sea, whales and dolphins use sound to talk to each other many kilometers away. Movement, or kinetic energy, is the energy of moving things. If you throw a ball, ride a bicycle, or run in the park, you use movement energy. Cars, trains, boats, and airplanes move using energy from fuel or batteries. Water flowing in rivers, wind blowing across the land, and even falling rain are full of movement energy. Stored energy, called potential energy, is found in many places. A rock at the top of a hill has potential energy because gravity can pull it down. A stretched rubber band, a raised hammer, or water behind a dam all hold potential energy. This type of energy is waiting to be used, and when something happens, it quickly turns into movement, light, or heat. Chemical energy is held inside food, batteries, fuel, and living things. When you eat fruit or bread, your body turns chemical energy into movement and warmth. Cars burn gasoline or diesel, and airplanes use special fuels. This releases chemical energy as movement and heat. Batteries are another way to hold chemical energy and change it into electricity when you need to power a flashlight, a phone, or a toy. Nuclear energy is energy that comes from the centers of tiny atoms. The sun and all stars get their power from nuclear energy. Inside nuclear power plants, people use nuclear energy to make heat, which then makes electricity. This kind of energy is very strong but needs careful control because it can be dangerous if used in the wrong way. These forms of energy are always changing and moving from one to another. For example, a solar panel changes light energy from the sun into electricity. A toaster changes electrical energy into heat, and a speaker changes electrical energy into sound. Even your body changes chemical energy from food into movement, heat, and ideas when you think or dream. Plants use light energy every day. With water, air, and sunlight, green plants make their own food through a process called photosynthesis. The sugar and starch in fruit, leaves, and roots are stored chemical energy. When you eat a banana or carrot, you are eating energy that the sun first gave to the plant. Rivers, lakes, and oceans are full of moving water. Hydroelectric dams use the movement energy of falling water to run big machines called turbines. These spin and make electricity for homes and schools far away. Waves at the shore and the ocean's tides also have movement energy, and new machines help capture it to make electricity. Wind is another source of movement energy. Wind farms are fields of tall wind turbines. When the wind blows, these large arms spin round and round. The spinning turns magnets inside the turbines, which then create electricity. This is a clean form of energy because wind does not produce smoke or waste. Deep underground, there is stored heat called geothermal energy. In some places, hot water and steam come up from the earth. People use this underground heat to warm houses, help grow food, or make electricity in special power stations. Fossil fuels such as coal, oil, and natural gas are another way to get energy. These fuels are formed from plants and animals that lived a very long time ago, sometimes millions of years in the past. Digging them up from the ground or under the sea, people burn them to make heat, electricity, or movement. These fuels have a lot of energy stored inside, but burning fossil fuels can also make smoke or gases that go into the air. In your kitchen, you use energy in many ways every day. When you open the refrigerator, cool air comes out because electrical energy runs the machine to keep food cold. When you use a microwave or stove, electrical energy turns into heat that cooks your dinner. Blenders and mixers use electrical energy to spin and chop food. Dishwashers use both electrical energy for movement and heat energy for hot water. In schools and offices, energy is everywhere. Lights shine, computers and phones work, radios and speakers make sound. Heating and air conditioning keep people comfortable in every season. Printers and projectors help teachers and students learn in new ways. Even the clock on the wall uses tiny amounts of energy to keep time for everyone. Transportation uses many forms of energy. Cars, trucks, buses, and motorcycles use fuel and batteries for movement. Planes use jet fuel. Ships use heavy oil or gas. Newer electric cars and trains get their energy from large batteries which are charged with electricity from many sources. Bicycles use energy from your own body, changing the food you eat into movement as you ride. At home, energy is important for comfort and fun. Televisions, video games, fans, washing machines, dryers, and vacuum cleaners all use electricity. Some houses have solar panels on the roof to capture energy from the sun. Others use gas for stoves or heating. Batteries help keep clocks, remote controls, flashlights, and toys working when no wires are nearby. Music, stories, and news travel by sound energy through speakers or headphones. The energy from your phone or computer changes into sound, and sometimes into pictures too. Artists use light energy from lamps and the sun to paint, draw, or take photos. Movie theaters use energy to light big screens and fill rooms with sound. Even sports and play use energy. When children run, jump, or swim, they turn chemical energy from breakfast or lunch into movement. Stadiums use lights and speakers for games, often needing a great deal of electricity to keep fans comfortable and entertained. Sound energy moves in waves, just like light or water. Loud sounds have more energy. Soft sounds use less. Some energy moves in small ways you do not notice, while other energy is strong and easy to feel. A whisper, a song, or thunder during a storm are all made by energy moving in different ways. Invisible energy is everywhere too. Radio waves, Wi-Fi, phone signals, and television shows travel through the air as special forms of energy. These signals carry voices and images far, even across the world, letting people stay in touch with family and friends wherever they live. Using energy in smarter ways helps people, animals, and plants. Turning off lights when not needed, using energy-saving machines, or walking and biking instead of always riding in cars can save energy. Growing trees, protecting forests, and cleaning rivers all help keep the world healthy, using less energy and caring for nature. Energy is found deep in space as well. Light from the sun travels more than 150 million kilometers to reach Earth. Energy from distant stars, planets, and galaxies travels for millions of years across the universe before reaching telescopes on Earth. This starlight helps scientists learn about space, the life of stars, and the birth of new worlds. Some energy is used up soon after it is made, like in cooking, playing, or lighting a room. Other energy is stored for a long time in places like batteries, gas tanks, wood piles, and even your own body as fat or sugar. When needed, this stored energy is turned into movement, heat, light, or sound. Many new inventions help capture, use, and save energy in better ways. People build wind turbines in fields, solar panels on roofs, batteries in cars, and tiny power banks for phones. Some cities are now filled with electric buses and cars, clean trains, and bright new lights that use very little energy. Scientists work on batteries that last longer, clean ways to make electricity, and better ways to store energy for later. Energy often switches between different forms. When you charge your phone, electrical energy fills the battery. When you unplug it, the stored chemical energy inside the battery turns back into electrical energy so you can use the phone again. A power plant makes electricity from moving water or burning fuel. A radio or speaker takes electricity and gives you music or news as sound. Farms also use energy. Machines plant seeds, water crops, and harvest food. Fences and greenhouses need building and care, all using energy. Food is packed, shipped, and stored using trucks, ships, coolers, and freezers. When food gets to a store or market, lights and machines keep it fresh and safe to eat. In hospitals, doctors and nurses use bright lights, machines that help people breathe, and computers for health records. Scanners, X-ray machines, and emergency equipment all need energy to save lives and help people heal. Every piece of clothing you wear was made with energy. Cotton, wool, or new fibers grow in fields or are made in special factories. Sewing, washing, and sending clothes to stores uses more energy. When you wash and dry your clothes at home, more energy is used. Construction uses a huge amount of energy too. Buildings, roads, bridges, and tunnels are made by machines that dig, carry, and build using powerful engines and motors. Cement, bricks, glass, and steel are made in factories that use heat and electricity. Workers use lights and tools powered by batteries or wires. Parks, gardens, and forests also show how energy works. Trees and plants take sunlight, water, and food from the soil, turning them into new leaves, branches, and fruit. Animals use the energy from eating plants and other creatures to grow, move, and have young ones. Rivers, lakes, and streams move as water cycles between earth and sky thanks to energy from the sun and gravity. By seeing and learning about all the forms of energy around you, you better understand how everything in life is connected. Each kind of energy brings something important, whether it is growing food, moving families, keeping people healthy, or helping you have fun and learn new things. The world is full of these forms of energy, always working together, always changing from one into another, and always making life possible every day. Every day, energy is at work all around you. It helps you move, see, and feel, and it is needed for almost anything to happen, big or small. Even as energy changes from light to heat, or from stored energy in food to movement in your body, something very important is always true. Energy does not disappear. Energy may move, change, or appear in a new form, but the total amount of energy stays the same from the beginning to the end of every action. This basic idea is called the law of conservation of energy, and it is one of the most important ideas in science. Imagine you are pushing a swing. When you pull the swing back, you give it stored energy. As you let it go, that stored energy turns into movement as the swing goes forward and backward. After a while, the swing slows down and stops. Where did the energy go? The energy did not just disappear. Some was turned into movement. Some energy was changed into heat because of friction in the chains and the air. Even if you cannot see or feel all of it, the energy is still there, just in new forms. This rule is always true, no matter where you look. When you drop a ball from your hand, the ball falls and has more movement energy as it goes down. The higher up you hold the ball, the more stored energy it has. As it falls, that energy changes into movement. When it finally lands, some energy is changed into sound and a little bit of heat from the impact with the ground. The energy changes from one kind into another, but if you could collect it all, the total would be the same as when you started. In the kitchen, you see this same rule. When you boil water, you use heat energy from a stove. The stove heats the pot, and the water inside starts to get warmer. As it reaches boiling, some water turns into steam. The energy you put in does several things. It makes the pot and the handle warmer, it makes the water hot, and it even heats the air around the pot. No energy is lost, but it spreads out in many places and changes forms. When you use a battery to turn on a flashlight, the energy stored inside the battery moves in wires inside the flashlight. It turns into light that helps you see in the dark, and it also makes a tiny bit of warmth inside the battery and bulb. The stored chemical energy in the battery changes into light and heat energy, but the total amount is the same. This rule about energy is not only true for objects you can see, but also for everything in the world, no matter how big or small. In huge machines, small insects, powerful rivers, or the burning sun, energy moves, changes, and spreads, but never disappears and is never created from nothing. If you were able to measure every bit of energy before and after an event, you would see that it always adds up to the same total. Scientists call the place or group of things being studied the system. A system can be a small thing like a cup of tea or something large like the whole planet. In a closed system, where nothing comes in from the outside and nothing leaves, the energy inside always stays the same amount. It might be hard to see because energy can become very spread out or hidden, but it is always there in some way. Energy often changes forms when you do daily actions. When you ride a bicycle down a hill, you start with stored energy at the top. As you begin riding down, gravity helps to pull you, changing your stored energy into movement. If you stop by squeezing the brakes, some of your movement energy becomes heat from the friction of the brakes and the tires. Even though your speed goes away and you come to a stop, the total energy was not lost. Some became heat in the brakes, some went into making sound, and a tiny bit may have shaken the ground. When you run, your body changes the chemical energy in your food into movement energy in your muscles. You get tired because your body has used up some of the stored energy, turning it into heat and movement as you run or play games. The energy did not disappear, it simply changed into heat, which leaves your body as warmth, and into movement that let you run. If you eat a meal afterward, you refill your body's energy stores by taking in new chemical energy from the food. Machines and engines show this principle all the time. When a car moves, it burns fuel in the engine, turning chemical energy into movement and heat. The wheels roll, but the engine and the exhaust pipe get warm, and the car may give off sounds. Not all of the fuel's energy goes into movement. Some is lost as heat or sound, but if you could collect every last bit in all the forms, you would find none was lost. In much bigger places, the rule is just as true. The sun sends energy through space to Earth. Some is used by plants as light, and some by people as heat or electricity. When plants use sunlight, they turn some energy into stored food. Animals and people eat plants, and their bodies change the stored chemical energy into heat, movement, and more. The energy moves from sun to plants to people and animals to the environment. Inside the Earth, deep underground, rocks are warmed by energy stored there from when the planet first formed. Volcanoes and hot springs show this energy coming to the surface. Even though the journey may take a very long time, the energy is still moving and changing, never lost. Some energy becomes so spread out that it is hard to use again. When a room is cooled by an air conditioner, the heat taken from inside must go somewhere else, often released outside into the air. This is why you can feel it warmer near the back of a fridge or air conditioner, even as the inside is kept cool. In science, there is another important idea called efficiency. Efficiency means how much of the energy you start with actually does the job you want. For example, in a light bulb, only some of the electrical energy becomes light. The rest becomes heat. In a car, only some of the chemical energy in fuel moves the car. The rest becomes heat or sound. Scientists and engineers try to make machines more efficient, so more of the energy is used for the important job and less is wasted. No machine is perfect, but learning about efficiency helps people use energy better. The law of conservation of energy does not only work with the energy you see each day, it works for everything, everywhere in the world. It works for the whole Earth, for each city, and even for your own body. It even works in places you cannot see, like inside atoms or far away in space. Sometimes energy can move between things through heat, light, or sound. If you sit near a fire, heat energy moves to your skin and clothes. If you listen to music, sound energy travels through the air to your ears. If you turn on a lamp, light energy fills the room and lets you see. Sometimes, energy is passed along many steps. For example, in a power station that uses coal or gas, chemical energy from the fuel becomes heat, then makes steam. The steam turns turbines, which make movement energy, which is then changed into electrical energy. The electricity travels through wires, and finally, in your home, it powers a lamp or fan. Each step changes the form, but the energy is passed along the whole time. Renewable energy sources like wind and sunlight also show this law in action. Wind is air moving because the sun heats different parts of the earth. When wind turns a turbine, its movement energy becomes electricity. None of the wind's energy disappears. It is simply caught and changed into another form so people can use it. In nature, there are examples everywhere. Waterfalls show the change from stored energy high above to movement as water falls. Rivers use this movement to turn wheels and make power. On a sunny day, sunlight enters water and turns to heat, making it warm. Even far away in space, stars and planets follow this rule. When a meteor hits the Earth, its movement energy changes into heat, light, and sound. When a rocket ship is launched, fuel is changed into hot gases and movement to send it up from the ground. Scientists trust this law because it always works. Again and again, in every experiment and everywhere in nature, energy is not created and is not destroyed. It just gets passed along, changed, or shared in new ways. This law also helps people plan for the future. If they want to use less energy, they can look for ways to waste less and keep more energy doing useful things. They can build better machines, use less fuel, and recycle more. Saving energy and using it carefully means there will be more for everyone and the world will be healthier. The law of conservation of energy can seem simple, but it explains every motion, every sound, every bit of light, and every warm or cool feeling. It is a key to building machines, understanding weather, caring for health, and growing food. It is part of learning how to use energy from the sun, the wind, the ground, and even from inside atoms. Energy also moves inside your body. Chemical energy from food is shared by every cell, organ, and muscle inside you. When you run or play, this energy is used up and turns into movement and heat, which you can feel as you warm up. When you rest, your body saves energy, storing some for later. People use this knowledge to improve daily life. Families use timers for lights, better windows for their homes, and newer cars that use less fuel. Cities try to make traffic move smoothly to waste less energy. Factories design better machines that do more work with the same amount of energy. Recycling and reusing things like paper, plastic, metals, and glass also use the law of conservation of energy. Instead of making things new from raw materials, it takes less energy to reuse or recycle what people have already used. This saves energy and natural resources at the same time. Learning about conservation of energy helps people at every age. Children can turn off taps, lights, and chargers when not in use. Teachers explain why turning off computers and radios saves energy for the school. Stores use doors that close quickly to keep heat or cool air inside. Hospitals fix leaks and turn off machines when not needed. Understanding energy is important for nature and wildlife too. By using less energy, people can keep air, water, and land cleaner for plants and animals. Parks and gardens can use solar lights, and farms can use water and wind power to grow food with less energy. There are many ways you can see the law of conservation of energy in action every day. When you eat, run, play, wash clothes, heat your home, use a phone, or watch a movie, energy can always be traced back to its source and its new form. The law is always at work, invisible but always true. No matter where you are, indoors or outdoors, at home or in the world, all the energy you use is part of a continual cycle of change. It is never lost from the universe. Even when it is stretched out thin and hard to use, it is still there. The earth, the sky, and the life all around are proof that energy is always moving and always being shared. The law of conservation of energy helps people make good choices. It teaches everyone to save energy, value it, and think about where it comes from and where it goes. Every person, every machine, and every part of nature plays a role, always following this law, keeping the balance of energy moving and changing within our world. The world is full of energy, and this energy is always moving, changing, and showing itself in many ways. You see energy warm your hands, hear energy in the music around you, and watch energy as light fills the room. The law of conservation of energy shows that energy cannot be made from nothing and cannot truly disappear. But even when you try to follow every step of energy in your life and the world, you may notice something strange. You can always measure what energy does, but you never find energy itself sitting alone, waiting to be noticed. You can see a lamp become bright, but you cannot pick up a handful of light energy. You can feel the heat of the sun or the warmth from a cup, but you cannot carry away a piece of heat in your hand. You watch things move, listen to sounds, and even taste energy in food. but you only see what happens because of energy, not the energy on its own. This is a deep mystery about energy. Energy is not a thing you can hold, taste, or see by itself. It does not have color, shape, edges, or a solid form. It is not something you can put inside a box to show a friend. Energy cannot be taken out of everything else and looked at alone. Instead, you always know energy is there by what it does. You see its actions in movement, warmth, sound, and light, but the energy itself is always hidden behind these changes. Scientists study energy in great detail. They spend many years measuring how much energy is in food, in the sun, in a battery, or in your own body. They can watch energy move and change with careful machines, writing down numbers and using special words. No matter how closely scientists look, they never find energy itself without it being part of something else. Sometimes, scientists talk about energy as if it were only a way to keep track of how things move and change. The word energy then becomes a way to talk about something that happens, like keeping a record. For example, when you eat, scientists can measure how much energy moves into your body and then how much you use or give off as warmth. But this measurement is about what happens, not about energy as a real object. Some scientists wonder if there is more to energy than what we see. Is energy just an idea that helps people explain movement and change? Or is it a real thing that is always present, even when you cannot touch or see it? These are big questions, and no one has all the answers yet. What is clear is that no matter how you describe energy, its effects are always real and important for life, for science, and for all technology. When you look for energy, you find it only inside the action, not outside it. If you stop everything from moving, take away all heat, and end every light and sound, there would be no energy showing itself. The room would be dark, cold, and still. No energy can be found hiding in the empty space. This is why scientists often say energy does not have its own form, but is only a way to talk about how things can work or change. Throughout history, people have learned more about energy by asking questions. Long ago, they noticed the sun made crops grow and kept people warm. They learned that food gave power to people and animals. They saw fire as a source of heat and light. Each discovery helped people learn how to use energy better, even if they did not know what energy really was. With time, scientists gave energy names, like light, heat, sound, and movement, and learned to measure how energy moves from one thing to another. People built machines, used fuels, and learned to store energy for later. As things became more complex, questions about energy's true nature kept coming. For every lamp that shines, for every car that drives, for every tree that grows, people ask, what is energy really? And is it real or just something in our minds? The answer is still not simple, because energy is unlike anything else in life. You can count the number of apples on a tree, measure water in a glass, or weigh a stone in your hand. You cannot pick up a piece of energy, show it like a toy, or put it on a scale to be weighed alone. You only find energy through the changes and actions it makes possible. Some scientists agree that energy is only a mathematical idea. It helps calculate how much can happen, or how things might move or change. Others feel energy must be something more, because everything in the universe depends on it. Without energy, nothing moves, nothing grows, and nothing changes. You might wonder if energy could exist without matter, or if matter could exist without energy. When scientists look at matter, even at the smallest level, they find energy moving inside atoms and particles. When they look at empty space, sometimes they discover small bursts of energy, even where there is almost no matter at all. This makes the question of what energy is even more puzzling. There are also special cases where energy seems to act in new and strange ways. In the smallest parts of nature, called quantum physics, energy can move in ways that are not like anything you see in daily life. Sometimes energy at this level appears and disappears, moves in jumps, or cannot be measured without changing it. In these special cases, scientists must use unusual math to keep track of how energy moves and changes. This makes it very hard to talk about energy as something you can see or pin down. Still, you always notice what energy does. When a storm comes, lightning lights the sky with energy. When a volcano erupts, huge amounts of heat and light fill the air. When you charge a phone, electricity fills the battery with power, but in each case, you do not find energy itself, you see its effect. Many people accept that energy is both an idea and a real part of every change and action. Energy can be counted, traced, and measured. It is part of every plan for a machine, every recipe for food, every sports game, and every journey into space. No one has found a box full of just energy, but every person knows energy is needed for anything to happen. This mystery makes energy different from most other things in the world. If you close your eyes and listen, you hear sound as energy moving through the air. If you open your eyes, the light from the sky or your lamp is energy reaching you. If you eat or run, you use energy inside your own body. Energy is always hidden inside what is happening or changing, not outside it. Around the world, people use the idea of energy every day. Teachers explain it in science class. Doctors talk about the energy in vitamins and food. Engineers build bridges and cars using the laws of energy. Workers build houses and power plants that move and change energy for people to use. Even farmers and gardeners plan how to use sunlight, water, and soil to grow crops. Everyone depends on energy, no matter if they think of it as an idea or a real thing. Because no one can find or catch energy alone, this makes people curious. People keep asking new questions. Some wonder if energy is everywhere, like an invisible background to the world. Others hope new tools or new science will one day show what energy really is. New discoveries may change the way energy is understood, just as people first learned that matter and energy can change into each other. People keep learning by following the path of energy, step by step. In every house, school, hospital, and city, people measure, count, and watch how energy makes things work. Scientists keep making new kinds of machines, solar panels, batteries, and computers that depend on the rules of energy. Each machine works not by holding energy, but by changing it from one form to another. Explorers look at nature in new ways, using the law of conservation of energy to study mountains, weather, plants, and animals. They use special sensors to measure heat in jungles, light in space, and even tiny changes inside living cells. In every one of these studies, they see energy only by what it does. Very often, new ideas about energy become part of new inventions or make life better for people. New ways of using sunlight, wind, or water energy help light cities and towns more safely. Better tools for cooking, building, and learning all use knowledge about how energy changes from one form to another. Still, in every case, people only see the actions energy allows, never the energy itself. This special nature of energy also affects how it is talked about in science. In some classes, energy is described as a property, something things have, not something that exists on its own. Energy is a way to describe what can be done, or what might change, or how much work something can make possible. It is used to predict what will happen, but it does not act like a thing you can touch. Some students and scientists think about energy as if it is always inside everything, ready to come out. Others see it as a number added up by measuring movement, heat, light, or sound. Both ways are useful, and both help people solve problems and do experiments. What matters most is that the idea of energy helps everyone know more about the world. No matter how energy is understood or described, it is always linked to the way the universe works. From the beginning of everything, energy has made stars shine, moved planets, built mountains, and allowed life to grow. Even if you cannot find energy alone, you can be sure of its importance because nothing would happen anywhere without it. Some of the biggest questions in science remain about energy. Is energy real the way matter and light are real, or is it only a way of thinking? Can there be new kinds of energy waiting to be found, hiding where people cannot measure yet? What happens to energy in places far away in the universe or deep inside the smallest parts of nature? Mystery also comes from how energy moves and changes. Sometimes it moves in big steps. Other times it seems to spread out everywhere, almost like it becomes nothing at all. But the math always shows that energy is still present, even if you cannot use it or see it. Throughout life, energy remains at the center of every change, every invention, every action. Schools, cities, and communities use energy to make life better, plan for the future, and help people learn and grow. Even when people do not agree about what energy is, everyone agrees about what energy does. This is why teachers, parents, and scientists keep asking about energy and want to learn more. Each year, new questions are asked and many are still waiting for answers. But what never changes is that energy, whether it is a thing or an idea, always shapes the world, brings people together, makes movement possible, and lets people dream and imagine. When you watch waves on the ocean, see the wind in the trees, or notice the warmth of the sun, you are watching energy at work. When you ride your bicycle, run with friends, cook a meal, turn on a computer, or listen to music, you are being part of the great story of energy. Even though energy itself is always hidden, its presence can be felt in every moment. The real nature of energy may be a mystery, but its importance is clear in every single part of life. Energy links you to nature, to other people, and to the stars above. The search to understand it goes on, and with every step, new discoveries help life grow, learn, and change. This search is part of what makes learning about energy so interesting, and it has made it possible for people to explore even the biggest and smallest parts of the universe. Questions about energy have led people to study not only everyday things, but also the smallest and largest places in the universe. When you look at the world around you, it is easy to see energy when the sun shines, when wind blows, or when you hear music playing. But energy is also present in places you cannot see at all, both much smaller and much bigger than the objects in your daily life. Scientists work to understand what energy does inside the tiniest pieces of matter and across the greatest distances in space. At the smallest level, there is a special kind of science called quantum physics. In quantum physics, energy does things that may seem strange. Energy is found inside every atom, which is the building block of all matter. An atom is made of even smaller parts called protons, neutrons, and electrons. These parts do not act like anything you can see in normal life. They move and interact in ways that are very different from bigger things. Yet, just like in big things, energy moves and changes inside atoms. Inside every atom, the nucleus is made of protons and neutrons. Around this nucleus, electrons move very fast. The energy inside an atom makes it possible for electrons to jump to new levels or to leave the atom when light or heat is added. Sometimes, small bits of energy move in jumps. They do not move in smooth changes. These tiny jumps are called quantum steps. A bit of light, called a photon, carries a packet of energy. When an atom or molecule takes in a photon, it can use this energy to change or to give off light of its own. Quantum energy is very important in nature. It explains why things look the way they do, why plants are green, and how people can see color. It also lets scientists build new tools like lasers and solar panels. Because of quantum energy, computers, phones, and cameras can work using very small pieces of electronic parts. Scientists have found that in the quantum world, energy can sometimes appear and disappear in ways that do not happen with bigger things. For example, particles can sometimes move through places that should block them or seem to be in two states at once. Energy can be shared between particles quickly, and sometimes energy pops in and out of empty space for a very short time. These effects are very hard to see unless you use special machines. Studying quantum energy helps people understand how the universe was born and how it works at its deepest level. Even though quantum energy is strange and often hard to see, it is always there, inside every atom, making life and all matter possible. Scientists use huge machines in laboratories to study these tiny pieces of energy and matter. On the other end, energy is a key part of the largest things in the universe. The force of gravity pulls stars, planets, and whole galaxies together. Gravity is a kind of energy too. It holds the Earth and the Moon together and makes apples fall from trees. In space, gravity shapes the path of all objects and controls how fast they move and where they go. Stars shine by releasing energy. In the middle of every star, including the Sun, atoms join together in a process called fusion. This changes the kinds of atoms and lets out huge amounts of energy. This energy travels outward as light and heat. For example, when you feel sunshine on your face, that energy started in the middle of the sun and traveled through space for more than 8 minutes. Some stars are much bigger than the sun, and the energy they give off can be enough to fill whole galaxies with light. Galaxies themselves are huge groups of stars, dust, and gas. They move and spin because of the pull of gravity. The energy that makes galaxies move has been there since the beginning of the universe. In every galaxy, countless stars shine and turn matter into energy all the time. The universe was born from a great beginning called the Big Bang. Scientists believe that at that moment, all matter and energy came into being. As time passed, the universe grew and stars and galaxies formed. Since the very first moment, energy has always been part of how things are born, change, and move through space. Some energy in the universe is easy to see, like light from stars. Other energy is hidden, like dark energy or dark matter. Scientists see tiny effects caused by dark energy and dark matter, but do not know exactly what they are. These unknown forms of energy and matter fill most of the universe, but they do not give off light or heat, and you cannot feel them. Still, their presence changes how galaxies spin and how the universe gets bigger. Black holes are another place where energy acts in strange ways. Black holes are places where gravity is very strong, so strong that nothing, not even light, can escape once it gets too close. When matter is pulled into a black hole, great amounts of energy are released. This can lead to exploding stars and bright flashes in space that can be seen by telescopes far away on Earth. Energy also moves between stars and throughout galaxies as powerful bursts called cosmic rays. These are very small particles that travel through space at almost the speed of light. They carry energy from exploding stars, far-off galaxies, and other events in space. When cosmic rays reach Earth, they touch the air and sometimes even reach the ground. Scientists use telescopes, cameras, and sensors to study energy coming from space. By looking at light from distant stars and galaxies, they can learn about the birth and death of stars, the making of new planets, and the nature of the universe itself. Every bit of energy that arrives from space tells a story about where it came from and what happened as it traveled across the universe. On Earth, energy from the sun drives weather. ocean currents, and all the patterns of life. The wind blowing across the land, rain falling in the forest, and the flow of rivers are all possible because of the ongoing energy that started in the sun and reaches our planet each day. Plants capture this energy and begin the chain of life. Even inside your own body, your cells and molecules work with quantum energy. The simple act of seeing something is started by a photon of light reaching special cells in your eye. Each bit of information your nerves send is a flow of tiny electrical charges, which are only possible because of quantum energy inside atoms. In the biggest questions of science, energy is always part of the answer. How do stars live and die? How did galaxies form? Why does the universe keep getting bigger? Scientists use knowledge about energy to find clues. As they look at the tiniest parts in the laboratory and the largest places in space, they see the same laws at work. Energy is always present, always moving and changing, holding together small and large, simple and complex. Gravity energy, sometimes called potential energy, shapes how planets move around the sun and how moons stay near planets. It holds rocks on the ground and keeps oceans in place. Gravity also brings comets and asteroids on journeys through the solar system, and it causes tides in the seas. The universe is so big that energy from very far away takes millions or even billions of years to reach Earth. When you look up at the night sky, many of the stars you see may no longer exist. Their energy left them a long time ago and has only now arrived for you to see. Some parts of the universe are so far that their energy is stretched out by the growing space between galaxies. Light that comes from very far away becomes weaker and changes color as space itself grows. This special energy is studied by astronomers to learn about how fast the universe is expanding and what happened in its first moments. Scientists have discovered that even empty space is not really empty. Quantum energy can appear for a very short time as tiny particles which then disappear. This energy is too small to feel or see, but in large numbers, it may affect how the universe grows and changes. Quantum computers and new medical tools now use ideas from quantum energy. Doctors can use scans to look inside the body with help from special energy from atoms. Small machines can sense tiny changes in energy to help with research, building, and safety. Every year, more is learned about both the very small and the very large forms of energy. In the tiny world, new materials can be made, and medicines can be found by looking at quantum energy. In the heavens, new planets, stars, and galaxies are discovered as scientists follow the path of energy across space. One big question is whether energy at the smallest scale and at the largest scale are linked in a new way. Do the secrets of quantum energy connect with the powers that guide galaxies? New tools like very large telescopes and powerful particle colliders help scientists look for answers as they study energy in both extremes. Even though much about energy is still unknown, everyone can see that energy shapes the world at every level. You are made of atoms, and each atom holds energy inside. You live on a planet that moves through space, held by gravity and warmed by the sun's energy. You eat food that started with a photon of sunlight. You use electricity and heat in your daily life, which comes from deep inside the earth, from water and wind, and from the shining sun. When people look for life on other planets, they often look for signs of energy. This could be warmth, light, or movement in the air and oceans of other worlds. Energy is seen as a sign that something interesting or even alive is using it. Scientists on Earth even search for tiny bits of energy in rocks from the moon or from far-off planets to look for clues. In your life, you may not see quantum particles or watch galaxies spin, but you are still part of this very big and very small story of energy. Every moment, atoms in your body use quantum energy to help you move and think. Every day, energy from the sun, which started far away and a long time ago, reaches you and all living things. The story of energy is not just about science, but also about everything people do: exploring, building, healing, and thinking. From the mysteries deep inside atoms to the secrets of galaxies and black holes, energy connects it all. Many more questions wait to be answered, but one thing is always clear. Energy, in all its forms, small and big, is a key part of life everywhere. With every new experiment, discovery, and invention, the journey to understand energy moves forward. The tiniest quantum leaps and the farthest shining stars are both parts of this journey. As people study more and ask new questions, new parts of this great story are found, helping to show the wonderful ways energy shapes the universe at every level. Energy is always present all around you, in every place you visit, and in every part of life. Every day, people need energy for many reasons. People use energy to prepare food, heat and cool their homes, have light at night, travel to school or work, and even use things that help keep cities and farms working. It does not matter if you live in a large city or far in the countryside. Everyone uses energy in some way every single day. The energy you use does not come from one place. It comes from many different sources in nature and from things people build. Finding the right sources of energy and using them well is one of the biggest jobs for families, communities, and countries. Some sources of energy can be replaced quickly and do not run out, while others can take millions of years to form again once they are used up. By learning more about where energy comes from and how it is used, people can solve problems, save resources, and help keep the environment healthy for everyone. The sun is the most important source of energy for life on Earth. Sunlight gives warmth, brings light, and helps plants make food. Solar panels use the sun's light to make electricity. These panels are put on homes, schools, and large fields. When the sun's rays touch the panels, a special material inside turns sunlight directly into electricity. This electricity can be used right away or stored in batteries to use at night or on days without sun. Using solar energy does not make smoke, does not need fuel, and does not harm the air or water. Wind is another very important source of energy. Wind moves the air and can be strong in many places, such as on hills, by the coast, or across open fields. Large machines called wind turbines catch the wind with their long arms. When the wind spins the blades, the machine inside the turbine makes electricity. Wind farms can have just a few wind turbines or hundreds working together. Wind energy does not need fuel, and it does not pollute the air. Water has also been used as an energy source for a very long time. Flowing water has a lot of movement. Rivers and waterfalls give energy when the water moves from high to low. In hydroelectric dams, water is kept in large lakes behind the dam. When the water is released, it falls down and spins big wheels called turbines, which make electricity. This electricity can light homes, schools, buildings, and even factories many kilometers away. Some places use the power from ocean tides or big waves to turn special machines and create energy. Other forms of energy come from deep below the ground. This includes fossil fuels, coal, oil, and natural gas. These fuels were once plants and animals that died a very long time ago. Time, pressure, and heat turned them into the materials people use today to run cars, cook food, and make electricity in many places. Coal is dug out of the ground and burned in power plants to make steam, which spins turbines for making electricity. Oil is pumped from under the earth or the ocean and is used to make gasoline, diesel, and other fuels for cars, ships, and planes. Natural gas is also found underground and burned for heating, cooking, and making power. Even though fossil fuels are powerful and easy to use, they have problems. When you burn coal, oil, or gas, they can make smoke, ash, and gases that go into the air. Some of these gases can make the air hard to breathe, change the planet's weather, and warm the Earth in ways that can hurt people, animals, and plants. It takes millions of years to make new fossil fuels, so they will run out if people use too much. For these reasons, many people are trying to use less fossil fuel and find other sources of energy. Another important energy source is called biomass. This is energy made from plants, trees, or waste from animals or people. People have burned wood for thousands of years to cook food and stay warm. Today, special kinds of crops can be grown to make fuels like ethanol or biodiesel. Even leftover food, grass, leaves, or farm waste can be turned into gas for cooking and heating. Biomass energy can be good for the environment if it is replaced quickly and used in smart ways. However, burning any kind of plant does make smoke, so it is important to use clean methods and plant new trees when old ones are used. Geothermal energy comes from deep inside the earth. In some places, hot water and steam come up from under the ground. People use this heat to warm buildings or make electricity by turning the steam into movement for turbines. Geothermal energy is used more in places with volcanoes or hot rocks under the Earth's surface, such as Iceland, New Zealand, and some parts of the United States of America. Some people use nuclear energy, which comes from the tiny center of certain atoms. In special nuclear power plants, atoms of materials such as uranium are split into smaller parts. This process lets out a lot of heat, which is used to make steam. The steam turns turbines, and then electricity is made. Nuclear energy makes a lot of power and does not put smoke or gases into the air. But it creates dangerous waste materials that must be stored safely for a very long time, and there are risks if a power plant has a problem or accident. In many cities and towns, energy for electricity, heat, and transport does not come from one source alone. It is often a mix of many different sources. Power companies sometimes use coal, gas, water, wind, sunlight, and nuclear power all together to provide enough energy for everyone. People and communities are learning to use energy in better ways. Solar lights can work even in places far from the city or electric wires. Some schools have their own wind turbines and solar panels. New batteries make it easier to store clean energy for use at night or during cloudy, still days. Cities are changing streetlights to use less energy and making buildings that need less heating or cooling. Houses are built with better walls, windows, and roofs to save heat in winter and keep cool in summer. Cars, buses, and trains use a lot of the world's energy. New kinds of vehicles can run on batteries instead of gasoline or diesel. Electric cars need to be charged with electricity, which can come from clean sources like solar or wind. Bicycles and walking paths let people move without using energy from fuel at all. In some countries, more and more buses and trains use electricity and pollute much less than before. Factories and farms also use energy in many ways. Machines run on electricity or fuel to make food and clothes, build things, and move products from one place to another. Farmers use energy for planting, harvesting, and bringing water to crops. In some places, solar panels help pump water or run lights in barns and greenhouses. Using too much energy or using it in wasteful ways can create problems. If energy comes from burning coal or oil, it can dirty the air and water, hurt animals and plants, and change the climate of the entire planet. Finding the right balance is important for every person and for all life on Earth. Many people and groups teach about saving energy. Turning off lights, unplugging chargers, using less hot water, and fixing leaks in homes and pipes are simple ways to waste less energy. Growing trees, cleaning rivers, and protecting forests all help to save energy in nature. In the future, new energy sources may be found. Scientists are studying many ideas, like getting energy from waves and tides in the ocean, or making safe and clean energy from hydrogen. There is also work on making solar panels and batteries that last longer, cost less, and are easier to use everywhere. Some people are even looking at ways to collect energy in space and send it down to Earth. Around the world, governments, schools, and communities are making rules to use energy better. There are plans to build more green energy projects, use fewer fossil fuels, and help people learn how to save energy in daily life. Some countries share energy with neighbors using long wires or pipes, so everyone can have enough, even when the sun is not shining or the wind is not blowing. Every person plays a part in how energy is used. Children, teachers, workers, and leaders all make choices that add up. Saving a little energy at home, school, or work makes a big difference when everyone helps. Communities work together to make clean energy projects, plant more trees, and build houses and schools that use less energy to stay warm or cool. As life changes, the need for energy grows. More people, more machines, and more cities mean more power is needed every year. But by using smart ideas, new science, and working together, people can have enough energy for now and for the future. Using energy well helps keep air and water clean, lets animals and nature continue, and makes sure there is enough for everyone. The story of energy sources is not only about science, technology, and machines. It is about people, families, and the way life moves and grows. Choosing the best sources, saving energy, and sharing new skills lets everyone have healthy and full lives. When you use the lights, listen to music, ride a bus, eat food, or just play outside, you are part of a big system that starts with the sun, the wind, water, rocks, and trees. Every part of life is linked, and every bit of energy you use began with a source somewhere in nature. Learning about energy sources helps people of all ages make better choices. Understanding where energy comes from, how it is made, and what it does to the world lets everyone care for the earth and each other. New ideas and inventions, respect for nature, and sharing energy wisely are all parts of solving problems and building a safe, bright future for generations to come. People everywhere are working hard to make smart choices about energy. Every time you turn on a light, ride in a car, or eat a meal, you depend on energy from nature and from things people have created. You now know that the world's energy comes from the sun, from wind and water, from deep inside the earth, and from old remains called fossil fuels. You have learned that energy can be found in many forms, always moving, changing, and never disappearing. Today, and into the years ahead, everyone is trying to understand how to use energy better, share it fairly, and protect life on Earth. There are still many big questions about energy that interest scientists, teachers, and families. One important question is how to make sure there is always enough energy for everyone, everywhere. More and more people live in cities and towns across the world. They need homes, food, learning, hospitals, and safe places to play. Every one of these needs energy, but the Earth's resources are limited. If people use too much energy in wasteful ways, there will not be enough clean air, fresh water, or green fields for future families. To help with this, many people are looking for new sources of energy that do not run out and do not pollute the Earth. Solar panels, wind turbines, and water power are all used more each year. These things are called renewable energy because they can be used again and again, and the Earth's sun, wind, and water are not used up. Around the world, entire communities use only clean energy some days each year. Some families have solar roofs, small windmills, or use rivers to make their own electricity. Even in the countryside, people can build small solar cookers or water pumps to help grow food and keep farms working. Scientists and engineers are busy looking for new ideas and inventions. Many work to build better batteries that can store energy longer and recharge quickly. Now, electric cars, buses, and bicycles can travel many kilometers on energy from the sun or the wind stored in a battery. New houses are made with special windows, walls, and roofs that keep warm or cool air inside, saving energy every day. People are growing new types of plants that make good fuels, do not need much water, and help remove gases from the air. Some inventors are even trying to get energy from new places. They are studying ways to use ocean tides, waves, or very strong winds high above the Earth. Others ask if it could be possible to collect energy in space using big solar panels and then send that energy back to Earth. Some ideas are already being tested, and others are still dreams for the future. As energy moves forward, people must also think carefully about nature and health. Burning coal, oil, and gas for energy puts smoke and gases into the air. These gases can trap heat around the Earth, changing the climate over years. This can lead to more storms, floods, droughts, and changes in nature that make life harder for animals, plants, and people. Cleaner energy leaves the air and water safer and helps keep all kinds of life strong. New technology also makes it easier for people to be smart about using energy each day. There are now lights that use much less electricity but still shine brightly. Timers or automatic switches can turn off machines and lights when they are not being used. Modern phone and computer chargers do not use power once the battery is full. In some schools and offices, the heat or cool air is changed in every room so that no energy is wasted. Saving energy can also help families and communities. When people pay less for power, they can buy more food, books, and other things they need. When families walk, ride bicycles, or take the bus, they use less energy and get more exercise, with more time to spend together and more money to save. Children and young people are learning about energy in new ways. Teachers explain how energy comes from the sun, flows through plants, moves into animals and people, and even runs all kinds of machines. Students use small solar panels, windmills, and water wheels to see how energy changes from one form to another. They learn how the food they eat, the clothes they wear, and the games they play are all connected to energy. Some children help teach their neighbors, friends, or families how to save energy and care for nature. Communities are making more plans to share energy wisely. Families join together to build solar stations or small wind farms. Towns and villages use shared tools to fix leaks, collect rainwater, and keep homes warm or cool without using too much power. City leaders plan green spaces, better buses, safe walking paths, and fast trains so everyone can move easily with less energy. In the countryside, farmers use drip irrigation or plant trees to block winds and save water and soil. All around the Earth, governments make new laws and promises to use more clean energy, to protect the air and water, and to spend less money on fuels that pollute. Scientists talk to leaders and show what happens when energy is wasted or when communities use cleaner power. In many places, large companies must now make new machines and create new jobs that help save energy and protect nature. Around the world, people also wonder about many mysteries of energy. Even though science has taught much about energy, there are still basic questions that remain. Is there another kind of energy that no one has found yet? Some scientists look for signs of dark energy, a kind of energy that may help the universe grow bigger each year. Others think about the oldest moments of the universe and ask how energy first began, or if it can ever truly disappear. These are some of the deepest questions in science, and they help drive people to keep learning and exploring. One of the most amazing things about energy is that it is always being used and always being renewed in nature itself. Sunlight falls on every part of the earth. Plants turn sunlight into food, and that food gives energy to all animals, birds, bugs, and people. Rivers move from high mountains to the sea, giving energy for life along the way. The wind blows and helps shape land, move seeds, and make power. Rain comes, helping plants and animals to grow, and then is lifted back up by the sun to start the cycle again. Even in cities, the energy cycle does not stop. Food is grown, packed, and delivered to stores and homes. People use energy to cook, clean, and travel everywhere. Machines help make clothes, build houses, and keep everyone safe and healthy. Every piece of metal, glass, plastic, and wood comes from a long line of work that starts with using energy from the earth, the sun, the wind, or water. As you grow, you will see more changes in the ways people find and use energy. New inventions will help make energy cheaper, safer, and better for the planet. Cities may become quieter as electric cars replace old engines. Rural places may have their own wind or solar energy, even if they are far from the next town. In the future, power from the sun, the sea, or the wind could be shared between countries, so no one will be without light or heat. Many jobs for builders, engineers, farmers, and teachers will be needed to build and care for these new systems. You may also notice the world learning to use resources with respect. Old things are fixed and reused more often. Recycling keeps glass, metal, and paper out of landfills and saves energy in factories. People find new ways to share, borrow, or swap what they need, instead of buying something new each time. These changes help save energy, care for nature, and bring people together. As more people join to use energy wisely, Earth becomes a better place for everyone. Life for plants and animals is safer and cleaner. Water stays fresh, air is easier to breathe, and wild places can be protected for children, families, and future generations. When you save energy by turning off lights or using less hot water, you join a global team working for a brighter world. Every part of your day is touched by energy. You wake up with warmth and light, eat food that stores the sun's power, play and move thanks to the work of your muscles, and use bright screens and fast transport because of countless changes in energy around you. You are part of a bigger world where every living thing shares this energy and helps it move forward. The search to understand energy will never stop. With each new idea, invention, or discovery, people find better ways to use what nature offers. The questions about where energy comes from, whether there are new forms of energy, and how best to use it will always be important. Every answer helps people build new things, heal sickness, shape land and sea, and care for each other. When you look at the stars, feel the sun, listen to music, or watch rivers and wind move through the world, remember that energy connects every moment and every living thing. The light in your school or home, the music in your headphones, the food on your plate, and the path you walk every day would not be there without energy flowing from nature and from everywhere on Earth. Your part in the story of energy is important. The choices you make to save, share, learn, and create matter to your family, your friends, and the world. Even small actions, when shared by many, can change how energy is used for years. The future is full of hope and promise because people everywhere are asking new questions, building new things, and caring for each other and for all living things. As time goes on, you will learn more and help write the next chapters in the story of energy. There will always be new ways to use, save, and understand energy, and new mysteries waiting to be explored. By learning, thinking, and working together, people everywhere can help create a healthy, strong, and happy world, powered by the energy that fills the universe and makes life possible for everyone.